Complete guide on how to answer a grade 12 mathematics paper 2. The first question that we're going to start with is about matrices. So we have been given two matrices, and you can see that in the other matrix we have x in it. And the question is, let us determine the value of x for which the two matrices have the same determinant. Now you know that the determinant of a matrix is the product of the major diagonal, so you have 2 multiplied by 7. Then we subtract the product of the minor diagonal, that is 6 multiplied by negative 2. So negative 2 multiplied by 7, we get negative 14. Then this is minus, but this is 6 multiplied by negative 2, which is 12, right? So that becomes a positive. Now, this is negative 14 plus 12, which is just negative 2. So the first matrix has a determinant of negative 2. Now, the second matrix is the minor diagonal, the major diagonal value product is x multiplied by 2, that is 2x, then minus negative 3 multiplied by negative 4 is 12. So that is 12. So the second matrix has 2x minus 12 as the determinant. But we are told that the determinant of the first matrix is the same as the determinant of the second matrix. Okay, so what we're going to do, we're just going to say the second matrix has the determinant 2x minus 12, which should be equal to the determinant of the first matrix, negative 2. Okay, this simple linear equation, let us add 12 both sides. Negative 12 and 12 on the left cancels. We remain with 2x is equal to, the negative 2 plus 12 is just 10. We want x, so let us divide throughout by 2. 2 and 2 cancels on the left, and 10 divided by 2 is 5. So therefore, the value of x is equal to 5. Okay? Second problem, we want to find the inverse of the matrix L. So we want L inverse, but what we know is that the determinant of L from the first problem was what? The determinant of L from the first problem was negative 2. Okay, now this is a 2 by 2 matrix, so L inverse will just be 1 divided by the determinant, which is negative 2. Then we are going to switch the entries in the major diagonal. So where there is 2, negative 2, we put 7. Then negative 2 goes on the bottom. And then we switch, or we change the sign of the entries in the minor diagonal. So this becomes negative 6. And negative 2 becomes 2 positive. Okay? Then at this point we can just multiply every entry in the matrix by negative 2, so that 7 becomes 7 over 2, but this is negative, right? Then 2 divided by 2 is 1, so this just is negative 1. Then 6 divided by 2 is 3, so there's negative and negative, so that is positive. And then the other one is 1 here as positive. So therefore, this is the inverse of the matrix. Okay. All right. So in this problem, we are told that a boy uses 2 different buses to go to school on a particular day. So the probability that the first bus is late is 0.2, and the probability that the second bus is not late is 0.7. So the question is, find the probability that on this day, both buses are late, 1, and 2, only 1 bus is late. So what we know is that the probability, I'll just write in shorthand, the probability that the first bus is late, okay, the first bus is late is 0.2, okay, and the probability that the second bus, I'll just say S, the second bus not late, we are told that it is what? 0.7. Okay? So this information is from the question. Okay. Now we want the probability that the both buses are late. Okay, but what we do not know is the probability that the second bus is late, because the question tells us that the probability that the second bus is not late, which is here, is 0.7. Okay, now remember the sum of probabilities in an event should be 1. So if the probability that the bus is not late is 0.7, then the probability that S being late would just be 1 minus 0.7. Okay, so the opposite of a bus not being late is a bus being late. So if not late is 0.7, then late is 1 minus 0.7, which is 0.3. So this is the information that we need. Now we can go ahead and answer the first problem. Both buses being late, it just means the intersection or the product. So the probability that F and S late, right? So this is just, so the first one for late, F being late is 0.2. Then S late is 0.3. Then we just take the product, okay? So you can use a calculator, you will find 0.06, okay? So that is the first one. Now, in the second problem, this one is a little bit tricky because we want that only one bus is late, okay? Only one bus is late, 3 points. So the thing that you need to understand here is that in either cases, you have one bus late and another one not being late, okay? So we want only one bus to be late. So what we are going to do, we are going to take the product. Remember, if only one bus is late, meaning that the other one is not late, and vice versa, right? So if F is late, we have 0.2. Then we take the product of S not late, which is 0.7. Okay, so 0.2 is F, which is late. Then S not late is 0.7. Then we add the opposite, right? If F is not late, we have 0.8. How did I find 0.8? I just did from the first one here, 1 minus 0.2, which is 0.8. So because F is not late, uh, S will be late, which is 0.3. Okay, so let me say one more time. What I did here is that, so I will highlight black, which is being late. So in the first one, F is late, so I have 0.2. Then 0.7 is coming from S, which is not late. Then in the second one, S is late, which is 0.3. F is not late, which is 0.8. Okay, so what I can just do now, I can just take the product. So 0.2 multiplied by 0.7 is 0.14 plus 0.8 multiplied by 0.3 is 0.24. And this is just 0.38. Okay. All right, so the second question is a quadratic equation. 3x squared minus 11x minus 1 is 0. So the key point of this question is to identify the value of a, which is the coefficient of x squared, is 3. And what is the value of b? B is the coefficient of what? Of x, right? Which is negative 11. And c is what? C is negative 1. Very good. Now, because it is not easy to factorize this equation, it cannot be factorized, right? That is why we are going to use the formula. And the formula says negative b plus or minus the square root of b squared minus 4ac divided by 2a. Now, at this stage, I just plugged in, right? So I plug in where there is b, I put negative 11. Where there is c, I put negative 1. And where there is a, I put 3. Okay? So when you plug in, you have, this expression here. Then I just multiply, like, right? So remember, you have to multiply, right? Negative multiplied by negative 11. Okay? So this becomes 11. Then 11 squared is 21. And 4 multiplied by 3 is 12. But we have negative and negative, so that is positive 12. Then you have 6. Then let us go ahead and finish this up. So we have 11 plus or minus the square root of, so what is 121 plus 12? Will just be 133. Good. 133, then I divide this by 6. Okay? Now, at this stage, we can use the calculator. So you put in the calculator the square root of 133, and this should give you 11. So I'll say plus, should be 11.532, and I divide this by 6. Then on the other hand, remember we had plus and minus, right? So this will be 11. Instead of plus, I have minus 11.532. Then I divide throughout by 6. Then when you carry out your calculations, you should be able to get 3.76. That is to 2 decimal places, and negative 0.09. Okay, so these are the values of x. This problem, we are looking for the equation of the normal to the given curve at a point 2, negative 4. So this is just a scenario. So y is the curve that is given, y, right? The curve in the graph in blue is our curve y, and the red line is the tangent to this curve, and the normal is just a line which is perpendicular, right? It meets at 90 degrees to the line on the tangent. Okay, so what we need here is there just one thing, right? That is the slope of the red line, which is the slope of the tangent. Okay, now remember we are given that y is equal to x to the power 3 minus 3x squared plus 3x minus 6. Okay, so remember the slope of a line m is just the change in the values of y divided by the change in the values of x. And in that case, in calculus, we say dy dx. Okay, you can say dy divided by dx, but we just read it as dy dx, meaning the change in the values of y divided by the change in the values of x. So let us differentiate. Now remember, when you have x to the power, say, n, the derivative of x to the power n with respect to x, right? This is just n. You drop your n, and then you reduce n by 1. Okay, so that is how we find the derivative. So in the same way, we drop the 3 and we write x and reduce 3 by 1. So this becomes a 2. Okay, now in the same way, we have 3 outside, but we drop a 2 and reduce the 2 by 1, so which is 1. Then plus, we have x, right? So x has the exponent 1. So 1 minus 1 is 0. Any number to the power 0 is 1. So we have a 3. Okay, then there is no exponent there is no x in 6, right? So you have just something like x to the power 0. When you drop a 0, everything becomes 0. So the 6 disappears. Okay, so this is the derivative of this function. But remember, we want the slope at the point P, and at the point P, which is 2, negative 4, the value of x at this point is 2, right? That is the entry in the first coordinate, which is 2. So let us see what is dy dx. So we're just substituting where there is x, we just put 2. So this becomes 3. 2 squared, this is minus, that is 6. 3 multiplied by 2 is 6. Then x is 2 plus 3. Okay? Let us go ahead and compute this. So we have 3 multiplied by 2 squared is 4. So 3 multiplied by 4 is 12. Then 6 by 2 is 12 plus 3. So you can see that 12 and 12 cancels. We just remain with 3. Okay? So meaning that the slope of the tangent is 3, right? So m here for, I'll just say tangent line. Tangent line is 3. Okay? Now remember, if you have the slope of a tangent, to find the slope of the normal, you just take the reciprocal of the slope of the tangent and take the negative, right? So meaning that m for the normal curve, right, or for normal line is just negative the reciprocal of the tangent line. So I just said negative 1 over 3. Okay? Now, we want the line, right? So we have the slope of the normal, which is negative 1 over 3. So therefore, we are going to use y minus y1, which is given by what? M x minus x1. So in this case, remember we have been given 2 comma negative 4 as a point. So that is what I'm going to use. So we have y minus y1 is negative 4. This is equal to the slope is negative 1 over 3. Then we have x minus x1 is 2. Now I just simplify, right? So since I have 1 over 3 on the right hand side, I can multiply the whole equation by 3, so that on the left I have 3y, right? This becomes a positive, negative is positive, then 4 multiplied by 3 is a 12. Then this is equal to negative x plus 2. Okay? So once again, the fraction on the right, negative 1 over 3, I multiply the 3 on the left and I multiply the negative 1 on the right. Okay? So we have that equation, which is almost done, right? So what we can do, we can just bring x on the left side so that this becomes x plus 3y. Then we can write 12 on the other side, which is just negative. So 2 minus 12, it becomes negative 10. Okay? So that should be the equation. X plus 3y is equal to negative 10. All right, so in this problem, we want to simplify this expression, which has a division, right? So what we can do, instead of working with a division, we introduce the multiplication symbol. But once you introduce your multiplication symbol, you keep what is on the left, and what you are dividing by, you multiply it by the reciprocal, right? So what is in the denominator goes in the numerator, and what is in the numerator goes in the denominator. So you have this expression here. Okay? Now, what we're just going to do here, we're just going to do the cancellation. So we are going to have a fraction here, right? I'm not going to expand them. I'll just cancel them the way they are. We have a fraction like that. So look at this. We have 8 in the denominator and 88 in the numerator. So 8 into 88 is 11. Okay? Then let us go to r. You can see that we have r to the power 3 in the numerator, and in the denominator it is also to the power 3. So it cancels. Even s, right? We have s squared and s squared. So s squared goes. What about t? When you look at t, in the numerator on the left here we have t squared, but in the denominator we have t to the power 3. Okay, so remember, this is just the same as t multiplied by t divided by t multiplied by t multiplied by t 3 times. Okay, so t cancels, t and t cancels, you remain with one t in the denominator, right? So this is t multiply 11 multiplied by 1, right? Because all the t disappears. Okay, now the next thing that we're going to do is let us check the denominator on the left. We have p to the power 3 and p to the power 3 on the right. Q to the power 3 and q to the power 3 cancels. Okay. All right, what about 48 divided by 22? Okay, so you can do some division, right? You can see that only 2 goes in 48 and 22 without leaving a remainder. So 48 divided by 2 is just 24, and 22 divided by 2 is just 11. Okay, but the beauty is that we have 11 in the numerator and 11 in the denominator, so this should simplify to 24 divided by t. Okay, 24 divided by t. The next problem is about a geometric progression with the first term, right? The first term is 189, the second term is 63, and the third term is 21. So the first question is find the common ratio. So number one, the common ratio, we normally write it as r, like that. Now the common ratio is just the next term divided by the preceding term, right? So this is just 63 divided by 63 divided by 189, right? 63 divided by 189, which I can reduce this to 1 divided by 3, okay? I mean, if you want, you can use 21 divided by 63, and 7 into, you can use 21 into 21 is 1, and 21 into 63 is just 3 times, okay? So this should be the easiest one. Okay, now the second problem, we want the fifth term, right? So number 3, we want t5. So t sub n is given by, this is a formula which is given, the first term multiplied by the common ratio n to the power, to the power negative n minus 1, right? Then we know that the first term is 189, and t here, n here is 5. Why? Because 1t5, okay? So t, the fifth term, t5 is, a is 189. The common ratio, right? The common ratio is 1 over 3. And n is 5, right? So this is 5 minus 1. Okay, so I just wrote just for clarity. Okay, so now this is just the same as 189 multiplied by 1 over 3 to the power 4, right? 1 minus 5, 5 minus 1. Okay, and this is 189 multiplied by, what is 3 to the power 4? You have 3 multiplied by 3 multiplied by 3 4 times, it's 81, right? So this is just 1 over 81. Okay, so since 189 is a whole number, this is just the same as divided by 81. Okay, divided by 81. Then we can just go ahead and reduce this, which should give you 7 divided by 3. Okay, so the second question, the last question says sum to infinity. So sum to infinity is given by s infinity, right? Which is the first term divided by 1 minus the common ratio. Okay, so here again, the first term is 189 divided by 1 minus the common ratio is 1 divided by 3. Okay, so you know how to simplify these fractions, right? One, so in the numerator, let me write here. In the denominator, I have 1 minus 1 over 3. You can see we have 1 on the left, but the denominator here is 3, so I can just multiply 1 by 3 over 3. 3 over 3 is 1, right? So the denominators now are the same. I subtract the numerator. 3 minus 1 is 2 divided by 3. Okay, so here this reduces to 189 divided by 2 divided by 3. Okay, But because I am dividing, I will multiply and flip, right? So this is 189 multiplied by 3 over 2. Okay? 89, 3 over 2. Then you can just put this on a calculator and you should be able to find 283 point, should be point 0.5 to one decimal place. And that's how we solve this problem, right? This question is about sets. So we have a certain school which offers French, Chinese, and Japanese classes, right? So a group of students were asked which language they had studied, right? So the following Venn diagram shows the results. Okay, so the first question says how many students studied at least one language? At least one language. So what it means is that when they say at least one language, it means that they had a language, they studied a certain language. Okay, there is no way they never studied any language, right? So what we're going to do, we're just going to add everybody who is in French, Chinese, and Japanese. You can see that there is a 15 outside here, right? Because the 15 is outside, these 15 people did not study any language. Okay, so in number one, at least one language will be 23 plus 20 plus 32 plus 5 plus 3 plus 7 plus 10. Each number is added once. Okay, so you can just punch this on the calculator, which I've already done in advance. This will be 100. Okay, so number two, we want those students who studied French and Chinese, but not Japanese. Okay, so we cancel Japanese. So what I can do, I can just shade the Japanese part, right? So these 10, they studied Japanese. These 3 and 7 did Japanese. Okay, so let me just do like this. These outside here, these in the circle, they studied Japanese. Okay, so those who did French or Chinese. So when they say French or Chinese, it means they can do both. At least they did study something, right? French or Chinese. Okay, so here we have 23 plus 20 plus 32. Okay, you can see that 23 they did Chinese, 20 they did both French and Chinese, and then 32 they did Chinese only. Okay, when you add this, you get 75. Okay, now the third one says one of the languages only. So these ones, they just chose one language only. So in French, we have 23, which is just one. Then in Chinese, we have 32. And in Japanese, we have 10. Okay, then when we add this, we get 65. Okay, that is only one, right? Nice. Okay, now the last question says this student neither studied French nor Chinese nor Japanese. Neither French, Chinese, or Japanese. 15, right? That is in the complement. Okay, so if it is not in this language to say neither, they can say if 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 French was maybe set F, then Chinese is C and J, Japanese J, the question can be find A union C union J complement. Yeah, that should be the right one. F union C union J complement. Those that are not in F, C, and J. Okay. All right, let us do a little bit of integration. So we have the integral of this expression, right? 6x squared minus negative 5x plus 2 with respect to x. Okay, so what we can do, we can write this, right? We can write this as 2, right? Then I write 2 here. I say x to the power 0 with respect to x. Okay, so I did x to the power 0 for a simple reason, okay? So let us look at this. So I will say, note that if you have the integral of x to the power n with respect to x, this will just be x, you increase n by 1. Remember differentiation, you reduce by 1. Integration, you increase n by 1. Then this new exponent where you have added 1, you take it in the denominator, plus 1. Then you add a c in general, okay? So we're going to do the same, but remember here we have the integral. Let me write this again, 6x squared. I've ignored the limits, but I'll include them. 5x plus 2x to the power 0 with respect to x. So when you have the integral of a sum is just the same as the sum of integrals. So I can distribute the integral, which is the integral of 6x squared with respect to x minus the integral of 5x with respect to x, then plus the integral of 2x to the 0 with respect to x. Okay? Now, let us go ahead and apply that method. Okay? So remember again, we're just increasing the exponent or the index by 1 and dividing by the new index. So 6 remains the way it is, x, 2 plus 1, divided by 2 plus 1 is just 3, so I'll just write 3 in advance, minus 5x, 1 plus 1, right? The exponent on x is 1. 1 plus 1, which is 2 in the denominator, then plus 2, right? So remember I said we add 1, so there was a 0 plus 1, which is just 1, okay? Now let us go ahead and simplify this. So you have 6 divided by 3, which will be 2. Then we have x, 2 plus 1 is 3. Then minus 5 over 2 remains the same. Then we have x to the power 2, that is 1 plus 1. Then plus 2x, 0 plus 1 is 1, right? I don't need to write to the power 1. Anything is to the power 1, right? Okay. So this is what we get when you do your integration. Okay, this is what you get when you do your integration. Now, this is the point where you need to understand very well, right? Because this expression, right, this integral has limits from -3 to 1. So what we can do, we are going to substitute where there is x, we put 1, we find the value, and then we put -3, we find the value and find the difference. So we start with what is on top, which is x is equal to 1. So when x is 1, you have 2 multiplied by 1 to the power 3 minus 5 over 2, 1 to the power 2. This is plus 2 multiplied by 1. Okay? So you can go ahead and simplify this, which is just, 2 minus 5 over 2 plus 2. When you simplify this, you should get 3 over 2, like that. Okay? Now, I keep this one. What I'll find next is what I'll subtract, okay? So we have x, when x is -3, that is the upper limit, okay? I mean the lower limit. So this becomes 2, where I put -3 to the power 3 minus 5, 2, -3 squared plus 2, -3, okay? Now I'm going to just simplify this. This gives me, should be -54, because the exponent on -3 is an odd number. So -3 multiplied by -3 is positive. Multiplied by -3, it becomes negative. And this is minus, should be minus 45 over 2. And this is minus 6. Okay? So again, when you compute this, when you put this on your calculator, you should get something like 165 divided by 2. Okay? Now, this should be negative, right? Because everybody is negative. Okay? So therefore, the final answer should be the first value, which is 3 over 2, then minus what we found here, negative 165 divided by 2. Okay, this is just the denominators are the same, so we can just go ahead and add the numerators. So that is 3 plus 165 divided by 2, and this is just 168 divided by 2, which is just 80, 84, guys. Let us do this interesting problem, which is about pseudocode. So we're going to write a flowchart. So flowchart, trust me, is very simple. So we have start, that is one, right? Then we need to enter the radius and theta. Then there is a condition, if condition. Then we want to print, then else what happens, then we do and if, we print a and we stop. Okay, so let us go ahead and draw. Okay, so remember, when you are starting and you are ending, you use a circle. So I write a circle like that, nice circle. Then I write inside start. Okay, I write inside start. Then when you are entering numbers, you use a rectangle. Okay, so I draw an arrow that is flowing down, and in the rectangle I'm going to write enter. We are going to enter the radius and theta. So that is the rectangle. Okay, then the next thing is we're going to use a condition. So the condition is if r is less than 0. Okay, so remember, when you are when you are using the condition, right, when you're implementing the condition in the flowchart, you use a rhombus. Okay, so a rhombus looks like this, right? That is it's just like a square which has been twisted. Is it 90 degrees? Yeah, 90 degrees or 45. Okay, let me just say 45 degrees. Okay, so here you put a question, right? So if the radius is less than 0, so the question that you're going to put is, right, is, you are asking yourself to say, is the radius less than 0? That is what we put. Then you are going to have two options, right? It's either you have yes, it is less than 0, or you can say no, right? No. Okay. Now let us go ahead and read again. So the question says, if, right, if the radius is less than 0, then you print error, right? You print error. You say radius must be positive. Okay. So this is what we're going to print. So if the radius is less than 0, we say error. So remember, when you're printing, you have a rectangle also. Okay. So I write a rectangle. So since we said yes here, we're going to print error, comma, radius must be positive, like that. Okay. Now let us stop here a little bit. Then the prompt says else, right? The command says else area is given by that. Okay, so else, it means the radius is not negative, right, or is not less than 0. So else we say, let me go ahead and write what we're going to put inside here. Else we say a is given by 1 over 2 star radius star radius star sine theta. Okay. Now, what happens after you do that? We are going to end, right? But because this is a flowchart, we are going to print, right? So here we are going to print. We're going to print. We're going to print A. Okay. Then after printing A, we are done, right? So this should be a nice stop. Okay. But on the other hand, When the radius that is being given is less than 0, you print error, meaning that you have stopped, right? You print error, you cannot do anything. So we're going to connect the print message to the stop here, okay? And this is how we construct a flowchart. This is an exciting problem because we want to show that these 3 points are collinear, okay? So what does it mean when points are collinear? It means that they lie on the same line, right? When you plot them on the graph, they are on the same line. So if points are on the same line, it means that the gradient between those points should be the same. Remember, these are 3 points, meaning that you can connect two lines together and the other two together, right? So the gradient between them should be the same. So what we are going to do, we are going to use this nice formula. M is y2 minus y1 divided by x2 minus x1. Okay, now I will use a subscript, right? Okay, let me say I want to find the gradient or the slope between the point 2 comma 1 and a. So I'll say m, then I'll say sub ra, that is the gradient between r and a. So this will be, so let me take my a to be the second point. So y2 will be 7 minus y1 will be 1. Then I divided by x2 will be 4 and x1 will be 2. Okay, so this is my second coordinate and your r is coordinate in the first, right? Okay, so let's go ahead and just do the subtraction. 7 minus 1 is your 6 and 4 minus 2 is 2. When I do a division, you get a 3. Okay. In the same way, I can find the slope between A and B. Okay. So I'm starting with A as 1, then B becomes my second coordinate. So y2 is 16, which is in B, minus y1 is 7, right? Then divided by x2 is 7 minus x1 is 4. Then let's go ahead and take the difference. 16 minus 1 is 9, 7 minus 3 is 3, 7 minus 4 is 3, and 9 divided by 3 is 3, guys. Okay? Now, we can see that the slope is the same, right? If one is not convinced, you can find the slope between R and B. So there is M, RB, right? Not the late Rupiah banda. This is just RB, okay? So B is 16 minus 1, right? Which is from R, and 1, this is 7 minus 2, okay? And 16 minus 1 is 15. 7 minus 2 is still 5. And 15 divided by 5 is 3. Okay, so because the slope between any of these 2 points, right? If you take 2 points, you find the slope, all of them are the same, you conclude that A, B, and your R are collinear. Okay, so that is how we show that points are collinear. The last question is about construction in this session, and we have dealt with construction before. I have put the link in the description and in the comment section where we have solved construction problems from 2025, 2024, 23, 22, and 21, I think so. Okay, so you can go ahead and look at those. Okay. All right, so this is how you handle the first section of grade 12 mathematics paper 2. Okay, so comment in the section if you want us to look at the second part, section B. Okay, and which other year would you want us to solve? So I'll see you in the next episode.